So we did look at implicit differentiation at the end of our last term. It's implicit, as I said previously, because we haven't got y is equal to, we've got y's and x's all mixed together in there, and the technique is slightly different. And I'm hoping that when we look at it, you'll go, oh yeah, I remember that. But if you don't, we'll sort of scribble at the side here a few little explanations as to why that technique actually works. So, if we find the coordinates of a turning point, we need to find out where dy dx is equal to nothing. So there's nothing different about that. But actually getting to dy dx is a slightly different technique. So, what I'm going to do is differentiate along the line. I'm going to differentiate each term separately. Rather than, as we've done previously, just differentiate one side, we're going to differentiate each term separately. I'm going to leave the y cubed and the 3xy squared just for a second. We'll come back to those in a minute. But we can differentiate minus x cubed as we would do normally. So what's the differential of minus x cubed?
Minus x.
Yeah. And the differential of 3 is? Nothing. There's nothing different about that. Now, what we've done there is we've differentiated with respect to x. Here, if I'm going to differentiate y cubed, I'm going to need to differentiate that with respect to x. You can do it with respect to y relatively straightforwardly. What is it differentiated to in respect to y? Y cubed differentiated to 3y squared. But that's differentiating with respect to y. I need to differentiate with respect to x. And to get around that, what do I need to write after the 3y squared? Anybody remember? Times dy dx. Well done, Bar. Okay. Now, for those of you that don't remember why that is the case, if I differentiate y cubed, what I'm trying to do is differentiate y cubed with respect to x. That's what I want to do. What I've done to get the 3y squared is I've differentiated y cubed with respect to y. That gives me the 3y squared. But to make it with respect to x, I need to times by dy, because they effectively cancel out, and divide by dx. So that's why the dy dx comes there. The differential of y cubed with respect to y is 3y squared. I get 3y squared times by dy dx. Remember that dot can be multiplied by.
How do you get the 3?
So what I've got to do is...
So dy cubed over dy.
Yeah.
Basically just differentiate.
Exactly.
So you just differentiate them and you times by that.
Exactly.
And that's what it is.
That's what it is. I'll leave that there for the time being then, okay? Now, so that's y cubed sorted. The next thing I need to differentiate is 3xy squared. So this is more complicated because 3xy squared is what? It's a technical thing, 3xy squared. It's a...
It's like two things to differentiate.
Two things, and they are what's connecting them? How are they connected?
The 3.
No, so it's 3x
Y.
times by y squared. So the thing's a product. And we have to differentiate a product like we did in C3 by saying u is equal to something and v is equal to something else. In this case, u is equal to 3x, v is equal to y squared, and then I need to do the u dx. Differential of 3x is 3. And the differential of y squared is
2y.
close. Times by. Remember, that's differentiated with respect to y. I need it with respect to x. But then we need to do y dx. Fantastic. And then we use the formula. So we've got v du dx, which is going to be 3y squared. And then u dv dx, which is going to be 3x times by 2y dy dx. 3x times 2y is 6xy dy dx. So I've left myself a no space there. So we end up with that thing there.
Sorry, one question.
Yeah, go.
An explanation on the right side.
This side here,
Yeah, do we need to understand it or just be
yeah. You'll not be asked to prove it, no.
Okay,
So you just need to remember it.
Yeah, if you remember to differentiate it and then add dy dx.
Exactly right, exactly right. So, now I have my expression here, and it contains dy dx's. Now sometimes the question might say, write down dy dx in terms of x and y, and you need to rearrange this. So you need to get this and this to the other side, factorise and divide out.
Do you want me to divide that middle thing by
So
something?
wait, what's the step after when you have the UV?
So once I've done this thing here,
Yeah.
so we're using the formula that the differential of uv is equal to v du dx plus u dv dx. That's what we do.
And that is.
And that's what this thing here is. So v du dx is y squared times 3, and then this times this, 6xy divided x. Okay. So as I say, you could be required to find out what dy dx is, and then you just rearrange it and so on. I might do that in a second, but you don't actually need to do that for this question. If you're trying to find out what the turning points are, you know what dy dx is. What is dy dx at turning points? 0. So we could say, so at the turning points, dy dx is 0. And then you can just swap that in to the expression and then see what happens. So if dy dx is 0, get that out of the way. So if dy dx is nothing, then we've got 3y squared times by nothing is nothing. We're left with 3y squared, 6xy times by nothing is nothing, minus 3x squared is 0. So when you've done this at C1, C2, C3, when you're looking for turning points, you tend to find an equation which is just x's. This doesn't always give you an equation which is just x's. Here we've got a mixture of y's and x's, which means that we need to do something further to finish the question off effectively. What's a good idea to do next, do you think? What will make things easy for ourselves?
Do we have to know random coordinates?
We do, but I'm looking at this, and this equation tells me where the coordinates will lie.
Where did you put the 3?
Where did I put the 3? Where do you
Oh,
think?
differentiation was 0.
Exactly. Yeah, that isn't, well, it isn't technically a circle, no, but it's... so what we've got here is this equation, the turning points satisfy this equation, and the turning points also satisfy this equation. So to find out where the turning points are, effectively I need to solve these two equations simultaneously. Which looks quite horrible, but they're not going to give you anything in an exam situation which is really, really horrible. And this actually does work out quite nicely. So what we're needing to do is to find the turning points and solve these two simultaneously. But I'm going to simplify this equation first, just to make it a bit more straightforward. So what can I do to simplify that equation?
What happened to the 3 after the bracket?
Could, or just divide by 3 would be easy. Sorry, Daisy, yeah?
I thought it
Sure. So if I divide by 3, I get that y squared minus x squared is nothing. Anything else we can do just to make things easy for ourselves?
So this up to be y.
Square root.
I mean square root it.
You could square root it. I wouldn't square root it.
But let's put it in
That-
2 brackets.
You could put it into 2 brackets, difference of 2 squares. You've got y minus x, y plus x is nothing. So therefore y is equal to, from this one, y is equal to x. And from the other bracket, y is equal to minus x. So those two separate equations here, I can now substitute into this one, and I should find out what my coordinates are. So for example, if I take y is equal to x first, and I substitute it into this equation, well, y cubed, well if y is equal to x, then that's going to be x cubed, plus 3x times by y squared, what's that going to be? So we've got 3x, y is equal to x, so 3x times y squared will be 3x.
3x cubed.
Okay. And then I've got my minus x cubed there, is equal to 3. And as it turns out, in this particular example, it's just an equation in terms of x cubed. So it's not difficult to solve. So how many x cubes have I got on this side? Yeah, so I've got 3x cubed is equal to 3. So therefore x cubed is equal to 3x cubed is 3, x cubed is... Oh sorry, Daisy, can't get that away.
Minus one
So x cubed is equal to 1.
Is it? Yeah, Kate, what's the question?
I need to do my already, but you know how dy dx is that a really long thing?
Yeah.
Why don't you just have the 3y squared and 3x squared?
Why? So why this thing here? Why is there a dy dx there?
No, so you have that really long equation there,
Yeah.
and then 2 lines below.
Right. So dy dx is nothing.
Yeah.
So this times by nothing is, so that goes. 3y squared is just 3y squared. That doesn't change. 6xy times by nothing is,
Okay.
so that goes. Yeah.
That makes sense.
Right. So the x cubed is equal to 1. So therefore, what's x equal to? If x cubed is 1, x is 1. And if x is 1, what's the value of y? 1, because we said that y was equal to x to start off with. So there's one coordinate, one turning point. It's at 1, 1. Okay? Same idea, but I swap in y is equal to minus x, and I end up with y cubed this time will be minus.
So y is x, x is 1.
Sorry?
So the answer is y is x and x is 1.
So x is 1,
Oh, because y is
because
x.
y is equal to x, is how we started it off, then. Yeah. So we get minus x cubed, so y is equal to minus x, we get minus x cubed, put it in there as well, minus x squared is plus x squared, so you get plus 3x cubed there. We've got the minus x cubed anyway, is equal to 3, and just doing a similar sort of thing, we end up with x cubed is equal to 3, so that tells us that x is the cube root of 3, and because y is equal to minus x, then y is minus cube root of 3, so my other turning point is root 3 minus root 3. So those are the coordinates of the two turning points.